This lesson focuses on a number of different machine components, and it's divided into different columns. So there are 1, 2, 3, 4 columns. This column gives you the name of the component, which is very important, and I'm only going to focus on the main name of the component. This gives you an idea of what it looks like in reality. This is the view that you will see in 2D, but this is very important, the convention. You need to know this for your analytical question, the convention, and you need to know the name. So I'm going to highlight those two specifically. This is just to give you an idea of what it's like. This they will ask you in the exam or test, and this is what you need to produce or present. So the first thing that we're going to be looking at is a compression spring. And I'm highlighting the word compression spring. You know what the spring looks like. There they give you a view of it. This is how you draw the convention. Center line here, center line there, center line there. It starts with a straight line and it ends with a straight line, and you just do it in that angle format. Let's go to the knurling. The knurling with a silent K is this component here. It's a wheel or a handle that has grip sections on the outside, and the grip sections could be either in a diamond format like it is there, or it can be just in a line format. That is basically what a knurling is. Then we go to the bearings. So these are bearings. You will find that the bearing has an inside casing and an outside casing, and there are balls separating the inside and outside casing. There you can see there's the axle, and the bearing fits perfectly on the axle, and there are the balls that go and separate the outside from the inside part there. This is how you draw the convention. Let's look at basically an S-brake, what we call an interrupted view. So this view shows you the actual shaft. Sometimes shafts are very long. You won't be able to fit it on a page, but you are allowed to draw the front and maybe the back part of the shaft or a certain component, or the middle part, and you have an S-brake like that there, which is slightly hatched at the top or at the bottom. But what it means is that this shaft is actually longer than this drawing here, that it continues. Then everybody knows what a spur gear is. That is a normal gear, which is a wheel basically with teeth on the side. We don't normally draw the teeth as it is in the pictorial view. So we draw it as a double line, like that there. Then we move to the S-brake again, just to show you a different way or on a different shaft. There it is, the shaft, different shafts, and there's S-brakes again. Then we have the basic treatment of symmetry, or when things are symmetrical. So symmetrical means that this one side here, this half here is exactly like that half there, or this bottom is exactly like that top there. When components are symmetrical, we don't normally draw everything, but you are allowed to draw one side, like there the draftsman only drew one side, and that was the half line there. This would have been a mirror image here, but he didn't draw it, not to waste time, but he included that double line here, like that, or it can be horizontal like that. There's only a quarter, because it also shows that it is symmetrical all around. Here the whole component, there only half, with the double lines here, which shows symmetry. We go to the opposite side of the page, where we have holes on a linear pitch. So that's holes in a single line. Linear means a straight line. So that basically tells us that we want to drill holes all around this linear line, horizontal and vertical. When you draw the convention, and I want to highlight the convention, you don't draw all the circles where you want to drill the holes, but you only indicate the centers of those circles and just one hole there. The same for holes on a circular pitch. There are a number of holes on a circular pitch like it is there, and to be able to identify where you're going to drill that in the convention symbol, you only need to mark the center points of the circle or the holes which you are going to draw, and you don't need to actually indicate them all. That saves a lot of time. We look at a dowel. The dowel, boys and girls, is basically a cylindrical metal, or it can be wooden, but in this case being mechanical, you will have a rod which is referred to as a dowel. It goes into holes to secure certain things. Then a square on a shaft. A shaft is normally a round component. There is a round component, and then there's a square section, and then there's a round. But when you look at it like this, you won't be able to say what it is. So normally it's indicated with a cross like that. Now we know. Here we won't know, but there we know. That cylindrical shape, that is a cylindrical shape, but this part here is a square hole through it. That is a square on a shaft. That crossing, that diagonal, so cross, actually tells us, as well as that cross there, that's a square, that's a square, this is a cylinder, that's a square hole inside, and that's a cylindrical shape. We have an external screw thread, which means on the outside, there is your bolt, and the thread on the bolt is on the outside, so it's external, and you will find that in the convention, it will be on the outside. We don't normally draw thread like that in mechanical drawings, but we draw it as a double line. You can see here as a double line, one faint line on the inside and a solid line on the outside. Let's look at the internal thread. So we will find that when a bolt goes into a piece of metal, the thread on the bolt will be on the outside, which is external, but the hole where the bolt is going to go into will have internal thread like it is there. Then a spline, square teeth around a wheel. Similarly, like the holes, you are not going to create all the teeth in the convention, but you only need to do the middle one and one on both sides of the center, and that would suffice. Then you continue with the double lines, which is the outside part of the teeth and the inside crest part. There, similarly like the serrated shaft, where it is pointing, teeth with points on the outside, you are going to draw maybe just one or two, one center one and one on both sides, and then you continue with the external line and the internal line, which is the crest of the teeth here, to be able to show that on the pulley or wheel or gear, to put it that way. And that is basically what it looks like in reality. I hope you enjoyed this video, and it makes a lot of sense that what we have discussed, you will apply all this information in your analytical and in your mechanical assembly drawings.